My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed second semester subject content and pedagogy of mathematics education at secondary stage as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: define pedagogical content knowledge, PCK. Pedagogical content knowledge, PCK, is the special knowledge teachers need to teach a subject in a way that students can easily understand. It is not just about knowing mathematics content, but also about how to explain it effectively, choose the right teaching methods, and connect it to students' everyday life. PCK combines 1. Content knowledge, deep understanding of the subject, like algebra, geometry, or fractions. 2. Pedagogical knowledge, knowing teaching strategies, tools, and ways to help students learn. For example, a teacher teaching fractions can use pizza slices or chocolate bars to explain the concept visually, making it easier for students to understand. PCK helps teachers predict students' difficulties, use real-life examples, design meaningful activities, make learning interesting. In simple words, PCK is knowing both what to teach and how to teach it well so that all students can enjoy and understand the subject. Next important short question is: 2. What is concept mapping in mathematics teaching? Concept mapping in mathematics teaching. Concept mapping is a visual learning tool that helps students understand and connect mathematical ideas. It is like a diagram or a map where concepts are written in boxes or circles and connected with arrows to show relationships. For example, when teaching geometry, a teacher can draw a concept map starting with shapes, then branch out into 2D shapes, circle, square, triangle, and 3D shapes, cube, sphere, cone. This makes it easier for students to see how all shapes are related. Benefits of concept mapping: makes complex topics simple and clear. Helps students remember better because they can see the connections. Encourages active learning as students create their own maps. Useful for revision before exams. In simple words, concept mapping is like creating a math roadmap where every topic is connected, helping students understand the subject deeply instead of just memorizing formulas. Next important short question is: 3. List 2 advantages of pedagogical analysis of mathematics textbooks. 2 advantages of pedagogical analysis of mathematics textbooks. 1. Helps teachers plan better lessons. Pedagogical analysis breaks down each math topic into simple teaching steps. For example, while teaching fractions, the teacher can first explain what fractions are, then show real-life examples like a pizza slice, and finally teach addition of fractions. This step-by-step planning makes teaching clear and structured. 2. Connects math with real life. It helps teachers design examples and activities that make math interesting and practical. For instance, instead of just solving numbers, a teacher can use shopping bills or cricket scores to explain addition and subtraction. This makes students enjoy learning and see the use of math in daily life. In short, pedagogical analysis of textbooks helps teachers teach smartly and students learn easily because lessons are planned with meaning, examples, and logical flow. It changes math from a tough subject to something fun and understandable. Next important short question is: 4. Mention 2 important concepts from Class 11 Mathematics syllabus. 2 important concepts from Class 11 Mathematics syllabus. 1. Sets and their operations. A set is a collection of well-defined objects, like numbers or fruits. This topic teaches students how to represent sets, find their union, intersection, and complement. For example, if set A is equal to 1, 2, 3, math lovers, and set B is equal to 3, 4, 5, science lovers, their union AB is equal to 1, 2, 3, 4, 5, showing all students who like math or science. This concept helps in solving real-life problems like surveys and data grouping. 2. Straight lines, coordinate geometry. This topic explains how to draw and analyze lines on a graph using slope and equations. For example, the slope of a road can be calculated using 2 points on it. The equation of a line, y is equal to mx plus c, helps in understanding patterns, maps, and locations. Students learn to visualize algebra through graphs, making learning interesting. Both these concepts build a strong base for higher studies in mathematics, science, and even practical fields like engineering and data analysis. Next important short question is: 5. Mention 2 evaluation strategies used in textbook pedagogy. 2 evaluation strategies used in textbook pedagogy. 1. Formative evaluation. This strategy is used during teaching to check students' understanding step by step. Teachers use small activities, class discussions, or short quizzes after every topic. For example, after teaching probability, the teacher may ask quick questions like, "What is the chance of getting ahead when tossing a coin?" This helps the teacher know who needs more help and gives students confidence. 2. Summative evaluation. This strategy is done at the end of a chapter or term to check overall learning. It includes tests, projects, or assignments that measure how much students understood. For example, after completing coordinate geometry, students solve a test paper with questions like finding the distance between 2 points. This checks their overall skills and prepares them for exams. Both strategies ensure continuous learning, help teachers improve lessons, and motivate students to do better. They make textbooks more interactive and student-friendly instead of just memorizing content. Next, Unit 8. Long questions. First important long question is: perform a pedagogical analysis of trigonometric functions. Pedagogical analysis of trigonometric functions. 1. Introduction of the concept. Trigonometric functions form the base of advanced mathematics and real-life applications like architecture, navigation, and physics. They help in understanding the relationship between angles and sides of a right-angled triangle. Students of class 11 learn functions like sine, sin, cosine, cos, and tangent, tan, along with their graphs and properties. 2. Objectives of teaching. To understand how angles and side ratios are connected. To develop problem-solving skills using trigonometric identities. To visualize periodic functions and their practical applications. To prepare students for higher studies in mathematics and science. 3. Prerequisite knowledge. Students should know: basics of geometry, types of triangles, angles. Concept of ratios and Pythagoras theorem. Knowledge of degrees and radians. 4. Teaching plan and approach. Introduction with real-life examples. Start with simple examples like measuring the height of a tree using its shadow. Use of diagrams and graphs. Show the unit circle to explain how sin, cos, and tan values repeat. Step-by-step explanation. Introduce values of sin, cos, tan for standard angles, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, through an easy table. Activities. Practice plotting graphs of y is equal to sin x and y is equal to cos x to understand periodicity. 5. Learning outcomes. Students can calculate heights, distances, and angles in real life. They can derive and use trigonometric identities. They develop logical thinking through proof-based questions. 6. Evaluation. Formative, small quizzes like find sin 30 degrees or prove sin superscript 2x plus cos superscript 2x is equal to 1. Summative, assignments on solving word problems or drawing trigonometric graphs. 7. Values developed. Logical reasoning and analytical thinking. Appreciation of mathematics in daily life, engineering, astronomy, sports. Example. If a ladder of length 5 meters leans against a wall making a 60 degrees angle with the ground, the height it reaches is 5 times sin 60 degrees is equal to 5 times 32 is equal to 4.33 m. Next important long question is: 2. Discuss the steps in analyzing sets, relations, and functions from a PCK perspective. Steps in analyzing sets, relations, and functions from a PCK perspective. Pedagogical content knowledge, PCK, means understanding not just the topic but also how to teach it effectively. Sets, relations, and functions are the foundation of Class 11 mathematics and need step-by-step teaching for better understanding. 1. Content analysis. Sets. A set is a well-defined collection of objects. Students learn representation methods, roster and set builder forms, types of sets, and Venn diagrams. Relations. A relation shows a connection between elements of two sets, represented as ordered pairs or graphs. Functions. A function is a special relation where each input has one output. Students learn domain, codomain, and range. 2. Learning objectives. Understand and visualize sets using diagrams. Learn how elements of sets are connected, relations. Understand functions as rules that assign unique outputs to inputs. Develop logical reasoning and classification skills. 3. Prerequisite knowledge. Students should know basic counting, numbers, and Cartesian planes to understand graphs of relations and functions. 4. Teaching plan and approach. Start with real-life examples. Sets. Set of all cricket players in your school. Relations. Students and their roll numbers. Functions. Each student has only one unique ID number. Use visual tools, Venn diagrams to explain set operations, arrow diagrams for relations, and graphs for functions. Step-by-step explanation. Introduce symbols like etc. with practice. Activities. Group activities where students create their own examples. 5. Evaluation methods. Formative. Quick questions like draw a Venn diagram for A is equal to 1, 2, B is equal to 2, 3, dot. Summative. Tests on identifying functions and solving problems using set theory. 6. Example. If set A is equal to 1, 2, 3 and set B is equal to 4, 5. A relation R is equal to 1, 4, 2, 5 connects elements. A function would ensure no input element of A has more than one output. This PCK approach makes the topic engaging, encourages reasoning, and helps students see math in real life, like IDs, mapping locations, or grouping data. Next important long question is: 3. How can activities and experiments be used to teach algebra and calculus topics? Using activities and experiments to teach algebra and calculus. Mathematics becomes more interesting and meaningful when students see and do instead of only memorizing formulas. Activities and experiments make algebra, and calculus easier to understand and help students relate them to daily life. 1. Teaching algebra with activities. Algebra is about patterns, equations, and relationships. Activity: balancing equations. Use a physical balance to explain equations. Place equal weights on both sides to show that if you add or remove the same weight, the balance remains equal. This helps students understand solving equations like x plus 3 is equal to 5. Pattern games: use matchsticks or colored tiles to create number patterns and write them as algebraic expressions. Example: show that a triangle pattern increases by 3 sticks each time, forming the series 3, 6, 9, leading to the expression 3n. 2. Teaching calculus with experiments. Calculus deals with change and motion. Experiment: slope of a curve, derivatives. Draw a curve on graph paper, place a ruler touching a point, and measure its slope. Repeat for other points to see how slope changes, introducing the concept of derivatives. Area under curves, integration: use graph paper to count squares under a curve, showing how integration helps find exact areas. Example: finding the speed of a car at a specific time by studying a distance time graph teaches instantaneous rate of change. 3. Benefits of activities and experiments. Increases interest and removes fear of mathematics. Makes abstract topics concrete through visuals and hands-on learning. Encourages teamwork, discussion, and curiosity. Builds logical thinking and application skills. Conclusion: by using simple materials like matchsticks, graph paper, and balances, algebra and calculus can become engaging subjects. Instead of rote learning, students develop deep understanding and see math in real-life situations like vehicle speed, construction, and business growth. Next important long question is: 4. Explain the need for enrichment of textbook content knowledge for effective teaching. Need for enrichment of textbook content knowledge for effective teaching. Textbooks are an essential tool for learning, but simply reading and teaching from them is not enough. To make teaching more effective, teachers need to enrich textbook content. Enrichment means adding more real-life examples, creative activities, and deeper understanding beyond the printed material so that students can connect concepts with practical life. 1. Makes learning interesting and practical. When teachers go beyond the textbook, lessons become lively. For example, while teaching probability, instead of only solving questions from the book, teachers can use coins, dice, or cards in class to show probability in action. This creates curiosity and excitement among students. 2. Builds deeper understanding. Some textbook explanations are brief. Enrichment helps students understand concepts thoroughly. For example, while teaching graphs in algebra, teachers can use graphing software or draw multiple graphs to show how changing equations affects curves. 3. Connects textbook knowledge to real life. By relating topics to daily life, students understand the use of mathematics. For instance, teaching mensuration can include measuring the school ground or calculating the area of a room. This shows that math is not only theoretical but also practical. 4. Supports different learning styles. Not all students learn the same way. Enriched content with diagrams, activities, puzzles, or digital tools helps visual and kinesthetic learners too. 5. Encourages critical thinking. When teachers ask higher-order questions, give puzzles, or real-life problems, like planning a budget using linear equations, students develop reasoning skills instead of just memorizing formulas. Conclusion: enriching textbook content makes mathematics easier, more enjoyable and meaningful. It turns a simple book lesson into an engaging experience where students explore, think, and apply concepts. A teacher who enriches the content becomes a guide who inspires learning rather than just completing the syllabus. Next important long question is 5. Prepare a pedagogical analysis framework for statistics and probability. Pedagogical analysis framework for statistics and probability. Statistics and probability are important topics in Class 11 mathematics. They help students understand data, uncertainty, and chance in daily life. A pedagogical analysis framework helps teachers plan and teach these topics effectively. 1. Content analysis. Statistics, organizing and interpreting data using tables, graphs, mean, median, mode, and standard deviation. Probability, measuring the chance of events happening, understanding outcomes, and calculating probabilities using formulas. 2. Learning objectives. Develop skills to collect, organize, and interpret data. Understand randomness and predict outcomes. Apply concepts to real-life problems like games, experiments, and surveys. 3. Prerequisite knowledge. Basic arithmetic operations, addition, multiplication, division. Understanding fractions, ratios, and percentages. Knowledge of sets and basic algebra for probability formulas. 4. Teaching approach. Introduction with real-life examples. Statistics, survey the number of students who like cricket or football. Probability, chance of getting ahead when tossing a coin. Use of visual tools, graphs, pie charts, and histograms to make data easy to understand. Step-by-step explanation, teach formulas gradually, like probability is equal to number of favorable outcomes divided by total outcomes. Hands-on activities. Roll dice or toss coins to observe probability. Collect classroom data and calculate average marks or attendance percentages. 5. Evaluation methods. Formative, quick exercises like find the mean of 5, 10, 15, 20, or probability of rolling a 4 on a dice. Summative, assignments and tests involving real-life data interpretation, probability trees, and problem solving. 6. Values developed. Logical reasoning and analytical thinking. Practical skills to handle data and uncertainty in real life. Appreciation of mathematics in science, business, and everyday decision-making. Example. If a class has 20 boys and 30 girls, the probability of randomly selecting a boy is equal to 20 divided by 20 plus 30 is equal to 0.4. Students can relate this to real-life events like predicting weather, games, or surveys. This framework ensures that teaching statistics and probability is interactive, practical, and meaningful rather than purely theoretical.